A big theme I like to explore on this channel is iterative design. I am always trying to learn from my mistakes and do better on each one of these projects. So I thought it would be fun to take a look at 5 different projects I did where I was trying to chase down the ultimate retro gaming experience. I wanted to be able to relive all of my childhood gaming memories without the need for like 20 different game consoles clogging up my living room. But this was a rabbit hole of epic proportions that has occupied my mind for the last several years. So let's take a look at the project that started it all, and then we'll see how I built on it. This is a Raspberry Pi 4, and we are going to transform this into a retro game console. In fact, we're gonna transform this into every game console up until about the Sega Dreamcast. Yeah, how's that for a throwback? We might even be able to get this to play Wii games, although that might be pushing it. Now that we're here in the shop, we can get started on the first step of this build, which is going to be building a case for this tiny little adorable computer. Because we're gonna be working with incredibly small pieces, I figured that this was a great opportunity to use my X-Carve. So over here on the computer, I have easel loaded up, and on it, I've got a bunch of pieces designed. These 3 that you can see on the screen here are gonna be made out of walnut, and then we have this other one over here, which is made out of the oak. One of the main things that I wanted to explore on this project was building things in layers. The design I had in mind wouldn't be possible to carve as a single piece, but by splitting it up into 4 cross sections, I was able to get the shape that I wanted. Although I should point out that we will have to then glue them together later. Out of a single piece of walnut, I cut the top, the bottom, and a front air intake. And then out of this small slab of oak, I created a middle section where I included a bunch of small circular cutouts. Later, we'll use these to embed some magnets that'll make the top section removable. Carving is now done, and all we have to do now is break all of these individual pieces out of the bigger piece. Somebody told me that a really good way to do this is just with a hammer and chisel. So we're gonna try that. Yeah, that actually worked pretty well. Now that we have our 4 pieces separated, let me show you approximately how they're gonna go together. Raspberry Pi is going to fit in here like so. And this one is the middle piece, although I have to carve a little bit out of the back of it. Then this one goes on top like so. And then finally, this one goes in the front. So a couple little fitment issues that I noticed right off the bat. Obviously, this guy is just way too thick and it looks kind of dumb as is. So I'll plane this down on the drum sander. And then the other thing I noticed is that this stack of 3 ends up being a little bit higher than that, so I will probably fix that by just reducing the thickness of this guy a little bit. Running small delicate pieces like this through a planer is a recipe for disaster. So instead, I opted to use my drum sander, which very gently removes a small layer of wood on each pass. This brought both our front intake and our middle section back into spec, but it took a lot of passes and a fair bit of patience. Now that we got those small issues taken care of, we are going to glue this midsection to the bottom section. And then we're gonna glue the front section on after that. I used to think that my larger glue-ups were tricky, but gluing together pieces this small presented its own unique challenges. Eventually though, I got the clamps to hold and left the glue to fully cure. It is now 24 hours later, and the glue is now definitely dry. So before we attach this front grille to the main chassis, I love coming up with little names for the pieces as I go, we had to do a couple little things to this first while we still have good, easy access to it. The first one is going to be widening this I/O port here. You can see that there's not quite enough room for all these USB ports and this Ethernet port here. So in order to fix that, I'm gonna have to expose one of my biggest weaknesses, which is using hand tools. I grabbed a little hacksaw and created 2 small relief cuts into the oak. Then I used a semi-sharp chisel to slowly carve away at the opening and create enough space for the Raspberry Pi's USB ports. Next, I did something that's gonna for sure make a lot of you guys at home cringe. I used the Pi itself as a template to drill some mounting holes. But hear me out here. There aren't actually any traces that run anywhere near these screw holes, so as long as you don't do anything too stupid, there's basically no risk here. Once that was done, I screwed in some small brass standoffs, lowered the Raspberry Pi into position, and screwed it down, only to discover a rather large issue with my design. So between this front grille and the actual board itself, there's a little area here which I was intending to use to put a fan, specifically this little one right here. But then I got it, and I was like, that's a little bit smaller than I imagined it would be. So I ended up ordering a different fan, this one right here, but this one is significantly thicker than the first one. But that's the nice thing about having your own CNC. I turned off the camera for like 5 or 10 minutes, and now I have a redesigned front grille that's ready to be carved. Being able to remake components like this on the fly is so handy. Can you imagine how heartbreaking it would have been to discover that mistake had I hand carved the front grille? Lucky for me though, I was able to carve a new piece with a new and improved design. This time I included a recessed area for the fan that held it tightly in place. No need for glue or even any mounting screws. Let's see how this guy looks now. Yeah, I think that should do the trick. Put that in there. And then, beauty. Okay, now we have the kind of clearance that we need. Although this is still looking a little bit too chonky for my taste, so we're gonna do the same thing we did before and plane it down on the drum sander. This fits in there very nicely now. Everything looks pretty good, so I think it's time that we glued the front grille in place. Paradoxically, when you're working on small pieces like this, wood movement can be even more of an issue than it normally is. I had to force this wedge into the front of the case in order to return it back to its original shape. After that though, it was an extremely straightforward glue up. It's about an hour later. See how we did. Nice. A couple little rough edges, but I've already set up a little area over here where we can clean those up. On my left here, you'll see that I've taped a piece of sandpaper to the desk. So by dragging the case over said sandpaper, I can reference that flat surface, smooth out any small imperfections, and create a very square and very true case. And because I'm doing it by hand, I can really dial in those little millimeter adjustments without worrying about accidentally removing too much material the way you might with a palm sander. Okay, so that's pretty close to where I want it. Now, before we go any further, I want to install all the magnets that I'm gonna use to secure this top to the main body here. Since all the magnet holes were machine carved, installing them was as easy as adding a single drop of CA glue and then gently tapping them into their individual holes. Once the glue's set, they were in there permanently. So let's see how these two halves fit together. Pretty good, actually. That's not bad at all. Okay, we gotta do a little bit more sanding to smooth out these edges, but then we'll be on to the finishing. This pass of sanding was more about shaping the case than it was about making sure everything lined up. I rounded off some of the corners by hand, and then I used a random orbital sander to do what my friend calls pillowing, where you slightly round and bevel your piece of wood. I felt like this little detail was kind of reminiscent of some of those rounded edges that were so popular in 90s gaming consoles, like the SNES and the Genesis. Look at that. That is looking pretty damn good. Now we're ready to do some finishing. And if you watched my last video where I was making that Bluetooth speaker, you know that finishing in these little slots is an absolute pain. So we're gonna try something new today. We are going to try spraying on the finish. After I got my makeshift spray booth set up, it was time to test it out. I loaded up some water-based varnish and gave it a spray. While this did end up working decently well, in retrospect, this sprayer was probably a bit oversized for the job. In the future, I think I'll have to invest in a little airbrush for smaller pieces like this. So now that the finish is dry, basically at this point in the normal video, we would almost be done. We still have quite a bit of work in front of us. So let's go home and install the hardware and then also install all the software that's gonna drive this thing. Remember earlier in the video, I said something like we might be able to get it to run some GameCube and Wii games? Well, in order to achieve that, we are going to have to overclock this thing. And if you aren't familiar with overclocking, what it means is you're basically pushing the hardware inside this thing to run faster than it was ever designed to run. And a byproduct of that is that it produces a ton of extra heat. So we are gonna need to upgrade the cooling on this thing. And we're gonna be doing that in two key ways. So the first of which is just this big relatively speaking fan that I installed at the front of the case. This is gonna blow air over the Raspberry Pi and keep it cool by dissipating the heat that way. The second way we're gonna cool it is with this guy. This is a heat sink and it attaches directly to the CPU on the Raspberry Pi and wicks heat away from it, which is then cooled by this fan right here. But even that is not enough to satisfy my thirst for maximum performance. So we're actually going to replace the stock fan on this heatsink, which by the way is like a little light up LED one, which I really didn't want in my case, with this high performance one from Noctua. This is quieter and it moves more air than this one. Fan unhooks, hook a little retention bracket on there, slide it under the heatsink. There we go, upgraded heatsink. Next, we have a little bit of a compatibility issue. You see, the power connectors that come with these fans aren't really compatible with the power supplies that are on the Raspberry Pi. These are DuPont connectors, and this is a DuPont crimper. So what we're gonna do is crimp a single female pin onto the end of each one of our wires. That will allow us to connect them to individual male pins on the Raspberry Pi. Of course, I don't have a wire stripper small enough to do these teeny little wires, so I'm gonna have to do it the old-fashioned way and try to strip these wires just using a little knife. I wanna just cut through the plastic shielding without cutting through the actual wire, which is a bit of a delicate operation. And then we have the pin and the crimp tool being held in there kind of. I'm gonna insert the wire in. Now with a little bit of luck, if I just crimp that on there like that, that should be connected. Yeah, seems pretty good. So now we have this little metal connector and we slide it into one of these little plastic sheaths. These are all extremely technical terms I'm extremely well versed in, as I'm sure you can tell. This guy just goes in here like so. So there's one. Now we gotta do 3 more. We'll just do a quick test here to make sure our fans actually worked and I hooked up everything right. And here's the power switch. And yeah, perfect. Both our fans are spinning nice and smooth. Let's move on. I'm going to use my main computer here to install RetroPie onto this SD card. Now, RetroPie is an operating system for the Raspberry Pi that is specifically geared towards emulation, playing retro games, and ROMs, and stuff like that. So in summary, pop the SD card into the main computer, write RetroPie to it, pop it out, pop it into the Raspberry Pi, and enjoy. So that's a freshly installed copy of RetroPie. We'll slide that into the Raspberry Pi like so. Now we're ready to install this in the case. Assembling everything inside the case was pretty straightforward, if a bit frustrating, but only because I was working with such small pieces inside an already tight case. Instead of using screws to mount the Raspberry Pi, I actually installed a second set of brass standoffs. This set of standoffs would in turn give me somewhere to mount the heatsink, but not before I installed a little bit of thermal paste on the CPU and a little bit of thermal compound on the RAM chip. These pastes help to facilitate heat transfer from the components to the heatsink, and they actually help quite a bit. Without them, the heatsink would be almost useless. So that's something you might want to keep in mind if you're planning on building a similar setup. Success! Everything fits inside the case. So the way this is set up to work is that fan at the front is gonna pull cold air in, it's gonna pass over the CPU and the heatsink, and then it's gonna get ejected out this top side. Now, let me show you one little compromise that I had to make on this build that I'm not overly thrilled about. So unfortunately, the Raspberry Pi actually has 2 sets of inputs and outputs. You have these ones around back, which are the USB ports and Ethernet, but then you also have this row of ports here. So this is the power supply, and then this one is the HDMI port. So in order to get those to work, I had to attach 2 right angle adapters to them. Now, obviously I could have just drilled another set of holes there for those cables, but I really wanted all the cables on this thing to come out the backside. So what I'm really gonna do is bring these around and over, and then I'm gonna route them through the top of the box. So this one will go there, that one goes there, and then they just come out the backside. Honestly, not the cleanest and most elegant solution, but it works for now. I think what I would do if I were gonna do this project again is have a cutout here and a cutout here, and then just run extension cables to those cutouts and then glue them in place. But you know what they say, first you make it work, then you make it look good. So let's get this thing booted up and see how it runs. Look at that, that is running quite nicely now. So give me a little bit of time to get this all set up, connected to the Wi-Fi, transfer over some games, and then we will take this thing for a spin. Okay, so that ended up taking a lot longer than I thought it would. I turned off the camera yesterday thinking it'd just be a couple hours, and it ended up taking the rest of the day. But regardless, I now have it set up in the living room, and it's ready to be demoed. As you can see, this is the initial splash screen once you boot up the console, and from here you can pick whatever system you want. We've got the NES, the NDS, the N64, the Sega Genesis, Game Boy, Game Boy Color, Game Gear, Dreamcast, basically every console right up to and including the PlayStation 1 and the PSP. And the best part is all of the games run great, and importantly, they feel just like they used to back in the day. Now, at this point, I should probably point out that running emulators and ROMs is a little bit of a legal and moral gray area. So for my system, I've stuck to only games and consoles that I actually own in real life. They just happen to be collecting dust in my dad's basement right now. The controller I've got here is actually pretty cool too. It's from a company called 8BitDo or 8BitDo, and it's basically like somebody mashed together a Super Nintendo controller and a PlayStation 2 controller. but it's completely wireless and it even has rumble functionality built into it. I just need to get like 3 or more of these so that my friends can play too. Another neat feature that this setup has is the ability to remotely manage it. Say I want to download a new game. I can just download it on my main computer and then drag and drop it onto the Raspberry Pi and it transfers over Wi-Fi. It's really seamless and really easy. Now, unfortunately, I did fall short of my own expectations in this build in a couple of key ways. One, I just don't love this design that much. It's not bad, mind you, but I just also don't feel like it's my greatest work ever. And two, I never really got it to run Wii and GameCube games that well. The fact of the matter is the GPU and the CPU in this thing, even when overclocked, just aren't powerful enough for those platforms. However, I am quite pleased with the way it runs Dreamcast and PlayStation games. And if there's one thing that I learned from Marvel movies, it's that you always leave room for a sequel. So that was the Everything Console Mark I, and I loved it. But it also left me with a burning desire for more. The hardware that powers this thing, the Raspberry Pi 4, just isn't strong enough to emulate some of my favorite game consoles like the GameCube, Dreamcast, and Wii. And to be honest, it even struggles with the N64 sometimes. So the Mark II began its life with an incredible stroke of luck. Oh boy, I might just be the luckiest SOB in town. The other day, I was sitting here and I was researching all of the parts that I would need to make the Everything Console version 2.0. And about the same time, I got a message from my friend and he said, "Hey Zach, there's a pile of laptops sitting in the corner of my office and I think my work is just gonna throw them away. Do you want one?" And of course, I said yes. So he came over the other day and he gave me this, which is an Asus Strix GL753VE. This might just be the perfect starting off point for the Everything Console V2, but it's looking a little big right now. This is a 17-inch laptop. So let's open this guy up and see if we can maybe trim some fat on this and get it down to a little bit more of a reasonable size. This is probably a good time to mention that a large part of the reason that this laptop was free was because there were quite a few things wrong with it. The Wi-Fi barely worked, the battery didn't hold a charge, and it was overheating like crazy. With the case cracked open, I started removing all the stuff that I wasn't gonna need anymore. Obviously, the battery had to go, but I also removed the mechanical hard drive and the Blu-ray player to free up some space. This left us with just the main motherboard that contained our CPU, GPU, 16 gigabytes of single channel memory, and a completely inadequate 128 gigabyte NVMe drive. Hopefully, with a few small tweaks and upgrades, we'll be able to squeeze enough performance out of this system. Okay, now this is a much more reasonable size for an Everything Console. And there's one other little thing I want to see if I can extract from this chassis. I didn't see that one coming. Here's the problem. The power switch is integrated into the keyboard of the laptop, but this keyboard is bonded to the chassis. So I think I'm gonna destroy it if I try to remove it. The real question right now is whether or not we can get this computer to boot outside of its case. I think I might have found a workaround on the internet. Apparently, if I bridge pins 1 and 2 on the old keyboard connector, I should be able to make the machine boot. Oh, did I get it? Lights are coming on. Oh, what was that? Oh, that doesn't look good. What's going on here? Is it the cable? Oh, there we go. Well, we got a little bit of repair to do. We have some upgrading to do, but we are functional. I think we better continue the rest of this video over in the shop. All right, so obviously we still have some stuff left to figure out with the actual computer part of the console. However, I'm in a mood to build something. So we're gonna get started on the case for the Everything Console V2. And in order to do that, we're gonna use a new toy that I just got. Let me show you guys. Between the Everything Console Mark I and II, I decided to upgrade my CNC. This new machine is larger, faster, and overall a lot more powerful. And we're gonna need that added horsepower to carve a new case for the Mark II because, well, it's gonna be a lot bigger than the Mark I. Even with the added speed, this was still a really long carve. While the CNC is busy over there doing that, we are gonna get started on upgrading this computer with some more performance parts and also upgrading the cooling a little bit so we can squeeze every last little bit of performance out of this thing that we can. Obviously, the first thing that had to go was the old Wi-Fi card. This new one supports Wi-Fi 6E, which should be faster, have lower latency, and, actually work. Then I replaced the old single channel RAM kit with a new dual channel kit. Theoretically, this should double our memory bandwidth, which should really help with performance and emulation.
Next, I swapped the old 128GB NVMe drive for a much larger 1TB model.
Look at all this floor space. So much aerobics in here. So many activities.
And then, just for fun, I threw on this big copper heatsink, which I don't really think it needs, but come on, it looks pretty sweet.
Finally, it was time to do something about this machine's poor thermal performance. I removed the factory heatsink and used some isopropyl alcohol to strip off that old dried out thermal paste. I then replaced it with some much higher performance stuff from Noctua. I also replaced all of the thermal pads with K5 Pro, which is essentially the same thing, but a little bit more flexible and way better performing. All of these small tweaks should hopefully add up to big performance gains later when we push this machine to its limits for maximum performance. But I'm getting ahead of myself. For now, let's go check on our carve.
That's it, we're done. So let's take a look at this. That took a little while to do. I think it was carving for about an hour and a half, which seems like a long time, but this is a really time-intensive carve to do. I actually timed it out on my old X-Carve, and it would have taken 8 hours to do that. So definitely a big step up in the speed category. Those first two pieces that we cut are going to be the top and the bottom of our case, and this piece right here is eventually going to be the midsection. It's not nearly as thick, so it won't take nearly as long to cut, which is good because I would like to get this thing assembled pretty soon.
Now, I did consider making this entire case out of solid walnut, but I cannot resist the call of a little accent strip. I had some birch ply left over from another project, and I thought its layered composition would make for a really cool look in our new case.
There we go. We got our midsection here. Now, I want to actually modify one of those pieces that we cut a few minutes ago. This piece right here is the top or the lid to the Everything console. And at the end of the day, the Everything console is basically just a PC. So I want to take a little bit of inspiration from the PC world and add a window. So what I'm going to do is flip this over, put it back in the CNC, and then we are going to cut an opening here. But the tricky part is I'm going to have to place it really precisely in order that I don't screw this whole thing up. But that's part of the fun, right? Okay, I think that's good. Wish me luck, everybody. Well, that actually went pretty well. Here's the plan. We have this opening here now, and in it, we are going to insert a piece of clear acrylic. But I've never cut acrylic before, and I'm sure there's going to be some learning curves. This stuff is notoriously temperamental. So I went ahead and just got 2 sheets of it because I'm kind of planning to screw up at least one of them. I'm going to swap from this big giant 1/4" bit that I've been using to cut all the walnut to this much smaller, teeny tiny 1/16 bit. It should generate a lot less heat and be better for precision cutting. I've also taken the liberty of adding a bunch of double-sided tape to the back of the acrylic. Not only am I going to be cutting out the general shape, but there's also some cutouts in the interior of the piece. I don't want those to go flying once they're free, which is a genuine concern even with this double-sided tape. So we'll see how that goes. Wish me luck. It's really annoying. The bit is so small and the dust shield is so close, I can't actually see whether or not the carve is going well.
A few minutes later, though, I could see the first signs of my pattern starting to peek out, and it looked like it was going pretty well. That smaller bit allowed me to carve these precise little hexagons that we'll talk more about in a second. But before we do that, one important thing that I forgot to mention earlier is that I was using cast acrylic sheets, which are supposed to carve a lot better than the cheaper extruded acrylic sheets that you get at most big box stores.
Moment of truth, let's see. Can we get this thing out of here? Yeah, okay. Good little peel action. No residue on the bed. Perfect. Look at that. I feel like this is gonna be pretty far up the list of satisfying peels. Oh yeah. Look at that. That is so cool. Love how this turned out. There's a couple little things we have left to do with this piece and putting it all together. But before we do that, we still have to cut the front grille.
In my head, I was kind of thinking of this piece as the front air intake, but in point of fact, it doesn't really function that way. This grille will be more like those decorative vents that you see on car hoods. Mostly just there to look cool, and at best, it'll provide a little bit of passive cooling.
Okay, let's see how that went. I think I might have made my lines a little too dainty and some of them might have broken. Well, I don't know, let's see. You know what? It's pretty delicate, but I think if I paint it and I'm very careful with it, this will work just fine.
One of the interesting things about MDF is that it actually gets a lot stronger once you paint it. All the small gaps in its porous surface get filled in by the paint, and what you end up with is a much denser material. So I was pretty liberal with the paint and applied a lot of coats.
All right, while we wait for the paint to dry outside, we are gonna continue by drilling some holes in our acrylic. This cutout here isn't just for fun. This is actually the functional air intake.
That's right, my plan here was to mount a fan just under the cutout and have it blast cool air directly onto the CPU and GPU. This should give us some additional thermal headroom that will allow us to overclock the GPU. But only the GPU, because unfortunately the CPU, being a mobile part, is locked from the factory. Also, shout out to Noctua, the company that makes this fan, for including these flexible rubber mounts that are perfectly color matched to my case. That was really nice of them.
On there like so, and there you go. We have the fan mounted to the top of the case. I think we're ready to move on to the bottom half of the chassis. Here's the deal over here. We have to find a way to mount this motherboard to the bottom of the case. So what I'm gonna do is take some of these little brass standoffs here and mount them to the bottom of the case wherever there was a mounting point in the original laptop's hardware. Should be pretty easy.
Just like with the Raspberry Pi project, I used the motherboard itself as a template. And just to prove that there's really nothing to worry about, I didn't even bother to find a straight drill bit to do the job.
So I think the next thing we should do is start assembling our case. But before we do that, we're going to do a little bit of finishing in all the hard to reach areas.
I think that this is good advice for any project you're building in multiple pieces. Finish all the hard to reach places while you still have good access to them, and then you can worry about doing a final finish later to tie everything together. Just make sure that you don't seal any of the surfaces you intend to glue together, because that's the next step on this build. First, I glued the midsection to the bottom, then I applied some glue into my channel and carefully seated the front grille into that, and finally, I glued the top piece in place, I clamped it all together, and I let it sit for about an hour. Once I was confident that the glue was dry, it was time to stylize my fake front intake a little bit. I set up a chamfer bit on my router and carved away at the inside edge of the intake. Again, not really functional, but I do think it looks pretty sweet.
Now that is starting to look a little bit more like a case.
Since I had already done all the hard bits earlier, this step was really quick. I just rolled on a couple of quick coats and then touched up the front grille area.
Look at that. That looks like a nicely finished case. So I've been trying to put this off for as long as possible, but I think now we have to do the step of this project that I have been dreading the most. Remember earlier when I got the computer to turn on by jumping to the pins on the motherboard? Well, that's not gonna work once this thing is in the case. I can't just be poking a screwdriver in there. So we're gonna have to wire up some sort of power switch. But take a look at just how small these connectors are. I have to solder wire to this pin here and the one next to it without them bridging or messing up in any way. I have my two wires, which I've pre-tinned with a little bit of solder. That means that I've melted some solder into the threads of this braided steel. I've got my soldering iron as hot as it will possibly go. So what I'm gonna do is just touch the wire to the contact and then hope that I can very quickly just tack welded in position. Not really a lot of room for error on this one, so still pretty nervous, and as you can see, my hands are not exactly very steady right now. Let's see, should I just go for one? Come on, baby. Oh, it was on for a second. Okay, one's on there. Okay, they're both on there. Okay, I don't want to celebrate just yet, because who knows if that actually even worked yet. So let's plug our power in, and we're gonna do a test run. It works. Check this out. So obviously I'm not gonna win any awards for best soldering job of the year, but this is what it looks like and it works, so you know what, I'll take it.
As the last little step here, I installed some heat shrink tubing to keep the wires from accidentally shorting out on each other.
Oh man, what a relief to have that done. Okay, so now we have to very carefully take this and mount it inside the chassis with the new standoffs. And after that, we can take this thing home and see what games it'll run. I mean, that's the biggest question on this entire project. It's gonna be kind of interesting to see where this actually kind of stops being able to perform. But I'm getting a bit ahead of myself. Let's get this thing mounted inside the chassis.
To improve the Wi-Fi and Bluetooth reception, I ordered a set of brand new upgraded antennas and then CA glued them discreetly inside the case. Then it was time to install all the standoffs and finally mount the motherboard. To power our new fan, I grabbed some extra long standoffs and used them to mount that USB daughter board from earlier. It sits just above everything else and gives me an extra USB port where I can install some LED lighting or another fan in the future if I want to. Finally, once everything was buttoned up, I prepared to take the Everything Console Mark II on its very first test run.
It's all assembled. This is legitimately my first time attempting to power it up. It works. Oh, what a relief. Let's take this thing home and see what it's all about. All right, it is a few days later. I spent some time getting all the software set up and integrating the console into my home theater setup here. And you know what? I think I even exceeded my own expectations on this build. Let me show you what I'm talking about. Obviously, everything from Atari straight through to Nintendo 64 and Dreamcast run flawlessly. But that was pretty much a given from the start of this video. Everything gets upscaled to beautiful 4K, you have multiplayer support, rumble functionality. It's pretty much the ultimate retro gaming experience. But what about some of those more modern day consoles? Well, I'm glad you asked, because both PlayStation 1 and PlayStation 2 run flawlessly. Ditto for the original Xbox. Wii games also run great too, although you do run into the occasional issue here like this where you need the motion controllers in order to make the games work, although if you look online there's usually some sort of workaround for those. And now for the surprises. Both the PlayStation 3 and the Xbox 360 run surprisingly well. I mean, it's not perfect, mind you, but it's pretty good. It's definitely playable. You get a couple stutters here and there, but these games didn't run perfectly on the original consoles anyways, so I would say that's a pass. And maybe the biggest surprise of all was that I got the Wii U to work pretty much perfectly. Simpler games like Mario run at a locked 60 FPS, but more complex games like Breath of the Wild do bog down a little bit into the lower 30s, mid 20s, stuff like that. But again, still very playable for these types of games. And of course, because this thing is just a PC at the end of the day, it'll also run every PC game. I mean, sure, it's not gonna run the latest AAA games at full 4K resolution, or will it? Well, here's the fun thing. Streaming technology has really evolved over the last couple of years. So if I find myself in a situation where I want to play the latest and greatest games out in the living room, well then I can just render them here on my much more powerful Office PC and then stream them out there to the Everything console. I mean, yeah, sure, there's probably going to be a little bit of added latency doing the whole round trip, but keep in mind I installed the latest Wi-Fi 6E hardware in that thing, and I could run a wired connection if I wanted to, so we're probably talking about latency measured in the single digits of milliseconds here. And again, because this thing is a PC at the end of the day, I can also use it like a home theater PC for transcoding movies and TV shows. Oh, and I should also mention that I upgraded to the Pro version of the 8-bit controllers that I used in the last one. Oh, and one other thing. Like all of the latest generation consoles, you can run the Everything console vertically or horizontally. The Everything Console Mark II represented a huge turning point for both me and this channel in general. See, that video performed really well. It might have even been one of my first videos to crack 1 million views. And that meant that I actually earned a little bit of money from it. Nothing life-changing, but enough that I had a bit of a budget to play with for the Mark III. So I wanted to see if I could use current gen hardware to A, push the emulation envelope even further, and B, to fix the primary weakness of the Mark II, which was size. Today, we are going to cram every game console up to and including the PlayStation 3, the Xbox 360, and the Nintendo Switch into a box that's about half or maybe even a third of the size of the Everything Console Mark II. This right here is a Minus Forum UN690, and it's a mini PC, but don't let the size fool you. This thing is a little powerhouse. Inside, we have a Ryzen 9 6900HX, a Radeon 680M, 16 gigabytes of DDR5 memory, and 1 terabyte of lightning fast NVMe storage. In its stock configuration, it already runs circles around the Everything Console Mark II. So naturally, we're just gonna take this thing and plug it in and use it as is, right? Wrong. Today, we are going to mod the software on this thing. We're gonna beef up the cooling, and of course, we're gonna design a completely new case for it from the ground up. Alrighty, so here we are in the shop. We have most of what we need to get started on this project. Honestly though, we don't have everything. So today we are going to be doing what I like to call working at risk. We do, however, have the most important part of this project, the mini PC. So let's crack this guy open and we'll start taking some precise measurements of it and start building the model for its new case.
I've got to say, hats off to the engineers and designers over at Minisforum because this thing was really easy to take apart. And as you're about to see, the internals are really well packaged too.
So now that we have it disassembled, you can actually see our unpopulated M.2 slot as well as our two DDR5 SODIMM slots. So we will definitely be having some fun with those later, but because we're just interested in measurements now, we actually had to break this thing down even further.
One thing that you're going to notice on this build is that I'm not even going to touch the stock heatsink, and that's because Minisforum installed it using liquid metal. Anything I might replace it with would probably just perform worse, so instead we're going to layer additional cooling on top of what's already there. But more on that later.
Oh, this is kind of sketchy because I have to like bend the case in order to get the PCB out. Oh, there it goes. Hopefully that wasn't the sound of something breaking. So there you go. On this side, you have the heatsink with the APU, the GPU, CPU combo underneath it. So now we can start taking some precision measurements of this and figuring out how we're going to carve our walnut to make a new case for it.
If it weren't for the Everything Console Mark 1, Mark 2, and my Xbox build, I don't think I ever would have had the confidence to attempt this one. And I really do mean confidence, because taking measurements like this isn't particularly hard, and designing the case itself is downright fun. But if you asked me a year ago if I ever could have done this, I would have told you no way. So it just goes to show, if there's ever a project that you feel like you want to do but can't, there's no shame in starting with something simpler and working your way up to it.
Woo! Okay, I think that's it for all the precision measurements. So let's run this thing through the CNC and see how I did.
I love my CNC, but a 3D printer it is not. It does have some limitations that I've had to find workarounds for. Like on this build, to compensate for its lack of vertical reach, I had to carve this recessed area for a fan and the sidewalls from one side, and then I flipped it over and carved all these through holes for ventilation from the other side.
Look at that. Our carve is now done. Got our ventilation holes. This is looking a little bit big, so let's machine this down to a more reasonable size.
Speaking of limitations of the CNC, when it comes to making straight, deep cuts along the outside edges, don't even bother. It's just so much faster to do it with conventional saws. And the same goes for bulk material removal too. If you need to thin out a piece, you're much better off using a planer, jointer, or in my case, a drum sander.
Now that we got the tops and bottoms done, let me show you how I'm thinking about mounting this thing. That is satisfyingly clicky. This right here is a motherboard standoff. And the nice thing about these is that you can actually kind of stack them or screw them together. And we're gonna use those to mount the PCB to the bottom of the case. So we'll just lower this in here. I'm gonna put a little piece of tape over this so that it doesn't move. Now, if you're at all squeamish, you might want to look away for this next bit because I'm going to use a little bit of percussive force in order to mark where these holes go. Let's see if that made some little indentations right where the standoffs go. Oh yeah, it definitely did because the board's now stuck in the wood a little bit. Come on, there we go. Oh, that couldn't have worked better. And just for anybody curious at home, board is still in one piece and everything's fine there.
In order to secure the standoffs to the bottom of the case, I drilled 4 holes that were just slightly smaller than the threads on the standoffs. And then I just kind of forced them down into the holes. The threads cut their own path and everything screwed down nicely.
So now the next thing we need to do is measure where all of our input and output ports are so that we can cut them into our side panels.
Truth be told, these were actually the most challenging measurements of the entire build. Everything had to be millimeter accurate, otherwise I wouldn't be able to use any of the ports on my mini PC. I also had to strategically locate a bunch of exhaust grills that will help to dissipate the extra heat that we're going to make once we start overclocking this thing. And rather than trusting all of my measurements to be 100% perfect, I kind of hedge my bets a little bit.
That is enough measuring, so now let's do some cutting. I'm actually going to start with this MDF hardboard, which is gonna act as kind of a proxy material.
If you're trying to figure out a complex shape or cut, it's often a good idea to substitute your intended material with a cheap, easy to cut alternative. Not only will it allow you to rapidly iterate through your designs, but it won't break the bank when you invariably screw up.
just like that, we have a cheap and easy to cut version of my front and rear I/O plates. Let's go see how my measurements did. Oh, ladies and gents, I didn't do bad for a first try. So the only one that I think I really need to move is this little LAN port here. It could be up a little bit higher, but outside of that, HDMIs look good. USB ports look good. Power port looks good. Yeah, that's really, really good. Awesome.
I don't know about you guys at home, but I am a sucker for seeing the internal workings of machines, and that's doubly true for computers. Something about being able to see all the chips makes me appreciate their ludicrous level of complexity. So it seemed only right that I make these side panels out of clear acrylic.
So that was the roughing pass, and now we're going to switch to a finer bit to do all the little detail work.
With the CNC, you trade speed for detail, because for detail, you need a small bit, and those are inherently fragile. To help work around that, you can use a larger bit to do the bulkier cutting, and then switch to a smaller bit to flush out all of your details. But no matter how you cut it, it's always going to take some time to cut hundreds of little hexagons. So while we wait, I cut some really aggressive chamfers on both the top and the bottom of the case. Once this thing is done, it's going to kind of look like a squared off hourglass, or maybe kind of like a TIE fighter. You'll see. Cutting the walnut revealed some pretty large cracks. Now, personally, I love how they look, but I also wanted to stabilize them, so I made sure to fill them with some brown CA glue. And unfortunately, because the fastest anybody could get me a set of new Wi-Fi antennas was 3 weeks, I cannibalized a pair from the Everything Console Mark II.
And just like that, we have our Wi-Fi antennas installed. And I think our acrylic carve just finished. So let's go check that. And yeah, unfortunately, that's not quite perfect. Despite my careful proxy work, these still need another revision. So let's just go ahead and carve those now. Okay, and now, thanks to a little bit of movie magic, we should now have two perfectly sized I/O plates. If I could just figure out which way this goes. Oh yeah, that looks a lot better. Well, I was waiting for that new piece to carve. I cut my old piece in two and I tried gluing them together. So the first thing I did was try this weld bond stuff. Apparently this works on glass and it dries crystal clear. However, on acrylic, it neither dried clear nor did it bond at all. So what I ended up with was just using a little bit of good old-fashioned CA glue, and that actually worked quite well.
Quick point of correction here, I actually mixed up weld on with weld bond. Weld on is actually supposed to work really well on clear acrylic, so I picked up a bottle of that for an upcoming build and we'll be testing it out real soon. Anyways, I basically treated this step as if it were a jewelry box glue up. I taped all the corners together to keep them aligned, then unfolded them, applied some glue, refolded them, and then waited for the glue to dry. Which thankfully in this case wasn't long because, well, CA glue.
That's what I love so much about CA glue is you can just like hold it for 15 seconds with your fingers and it's basically set. Yeah, you know what? That looks pretty damn good. So let's talk about performance. Some of you, no doubt, have noticed these two rather large Noctua fans. We are going to use these to cool the heat generating components of this computer and therefore give us more thermal headroom in order to overclock and squeeze every last little bit of performance that we can out of this thing. This first one's going to actually be incredibly easy to install. It's just gonna slot right here into the top of the case. Come on, get in there. It's a little bit tight, but yeah. Fits in there like that, and it's gonna blast cool air down onto the RAM and the NVMe storage. The second fan, on the other hand, isn't gonna be quite so easy. It goes in the bottom half of the case, but because we have these brass standoffs here, well, it doesn't really fit. So we're gonna have to modify it a little bit. Not to worry though, we will just trim our brand new Noctua fan over here on the miter saw.
I don't know why, but this just felt so wrong to do. I know I'm just cutting plastic on a miter saw, but you feel it too, right?
Now that we have both of our fans in the case, how exactly are we going to power them? Well, it's a good question, and it's honestly one that I struggled with for a while on this project. I explored a bunch of different ways of getting power from the main computer to the fans, and honestly, they all kind of turned out to be dead ends. But I did come up with a solution. It just happens to be a little bit janky, although it does come with a few advantages. Let me explain. So if you take a look at this rear I/O port here, you'll see that I actually added an extra I/O port there up at the top. That is for this, which is a USB Y splitter. So basically what I'm gonna do is plug this in here like so, and then I will be able to power the fans through external means. It'll look a little something like this. Is this the most elegant solution? No, it's not. But like I said, there are some advantages. One, I can maintain PWM control by putting a resistor in the extension cord. Two, I can actually operate the computer in 2 different modes. I can have a high power mode by just plugging it in and increasing the cooling power dramatically, and then I can have a low power mode for low-end emulation where it runs a little bit silenter. And 3, I didn't have to hack up anything inside the board. I don't have to worry about overloading any internal circuits or anything like that. So yeah, you have a little thing poking out, but I think this is actually the best solution.
And turns out there was actually another problem that I found when I went to assemble everything.
There's just too many damn wires in this computer case, so what we're gonna have to do is shorten some of these and just cut out some of the slack here in the system.
If you want to make custom computers, it definitely pays to be comfortable cutting and splicing wires. By hardwiring these fans directly to the USB plugs, I was able to cut out a bunch of wire and bypass some really bulky adapters.
That was a little bit of a deviation from my original plan, but now that we've got those shortened, let's see if everything fits together a little bit better now. Yes, success.
Once I knew everything would fit, I was on the home stretch. A little bit of sanding rounded off all the hard edges and gave the wood a nice smooth feel, and then it was time to seal the wood. To keep my pieces nice and stable, I was really diligent about oiling the entire piece all in one shot. You really want to avoid sealing just one side of a piece and then leaving the other side open, because that is an invitation for cupping and all sorts of other types of warping. Finally, it was time for the real assembly. Hot glue worked really well to hold the fans in position, and then CA glue did a great job of bonding the acrylic to the wood inside of these recessed channels. Once I had everything buttoned up, I was able to take a step back and admire the Everything Console Mark III.
And just like that, I think we're done. Or at least the physical case is done. Now we get to take it home and see just how much performance we can squeeze out of this with this crazy over-the-top cooling system. And also we'll talk a little bit about the software too. Let's go do that. So the first thing we're going to do is boot the computer into the BIOS, which I've already done, and we are going to raise its TDP. From the factory, this thing comes configured to SIP anywhere between 28 and 30 watts of power. We're going to crank that dial up to 11 and give it 54 watts of power. Next, thanks to our added cooling, we are going to be able to overclock the memory. From the factory, this thing comes configured at 4,800 megatransfers per second. I did a little bit of testing and we can safely crank that up to 5,600 megatransfers per second, which should theoretically give us an increase in our memory bandwidth of 15%, which will really help out the integrated graphics chip on this computer. Now that we booted into Windows, we have one last little tweak left to do, and this one's a little bit heady, but try to stay with me. We are going to undervolt the CPU. It's a bit counterintuitive, but by decreasing the voltage supplied to the CPU, we can actually make it more efficient, meaning it uses less wattage for the same level of performance, which allows us to squeeze more performance into our 54 watt power limit. So stock, this PC delivered a PC Mark score of 6,600 approximately, and a Firestrike score of approximately 5,200. Now, after our modifications, it delivered a PC Mark score of 6,844, which is not exactly the biggest increase in the world. However, it delivered a Firestrike score of almost 6,000. So not a bad uplift in terms of 3D performance. However, day-to-day performance, you probably wouldn't notice a huge difference. Next, let's talk about software and emulation. For the Everything Console Mark III, I wanted to have a much cleaner UI experience. So I went online, I did a little bit of research, and I found this program called Launchbox. Now, Launchbox isn't an emulator in and of itself. You can think of it more as an emulator organizer or maybe aggregator. Basically, what you do is you take all of your ROM files, all of your emulators, and you can link them together inside of Launchbox, and then it handles all the configuration and launching. So as you can see, I have my whole collection of retro games loaded up here. Everything from the Xbox and Xbox 360, which admittedly are not really that retro, the N64, NES, GameCube, Nintendo Switch, which I was actually really surprised by how well this ran. I mean, everything down to the PlayStation 2, PlayStation 3. The other nice thing about Launchbox is that it handles all the little details, like pulling down all the artwork for your different ROM files. I didn't have to do any of this. It just kind of configured itself. Basically, if they make an emulator for it, this PC will run it. And that kind of brings me around to my next point. I was so impressed by how well some of these emulators ran that I really wouldn't be surprised if once we see a proper PS4 emulator released and a proper Xbox Series One, no, Xbox Xbox One? What do they call the Xbox that came after the Xbox 360? I think that this thing will be able to run it. So I have a really good feeling about future-proofing. And also, because this is a PC at the end of the day, I can also run all of my favorite PC games, which also handily get pulled into Launchbox. With the completion of the Mark III, I didn't really have anywhere left to go in terms of emulation. This thing would handle basically anything that I could throw at it. It was compact enough that I didn't mind having it in my living room. And overall, I felt very satisfied with where I ended up. But then I started thinking, well, what if I wanted to play some of these games on a plane or on a long road trip? And it was also around that time when I got my first 3D printer and got started with 3D modeling. Today, we are going to make the ultimate mobile retro game console. And the best part is, you probably already own the most important component in this whole project. In fact, if YouTube analytics are anything to go by, you're probably watching this video on it right now. That's right. Modern day phones are actually pretty competent little emulation machines. They've got bright, high refresh rate OLED screens, wireless connectivity, and powerful enough GPU and CPUs that you can play even modern day game consoles like the PlayStation 2 and the Nintendo GameCube. Just plug a game controller like this Razer Kishi here into your phone, and you're basically good to go. Video over, and I will see you guys in the next one. Or, well, not quite. Yes, you could legitimately do that, but it would be like a 7 out of 10 experience. Your battery life would be kind of crappy. This whole thing feels kind of cheap and creaky. And once your CPU starts to thermal throttle, you're gonna notice some performance issues. So today we're gonna put our DIY skills to use, and we're gonna try and craft something that's a little bit closer to a 10 out of 10 experience. In fact, I actually went out and purchased a second phone specifically for this project, because by the time we're done with it, it's not gonna function very well as a phone anymore. Now, that might seem like an annoying YouTuber flex, but I actually got this Samsung S21 FE, which is in mint condition and has some pretty top-end specs for 250 Canadian dollars. So it didn't exactly break the bank. And I will tell you exactly how I did it and how you can do it at home, but first, we have to start disassembling this thing.
It all starts with a super evil scam. People will sell you a phone and then report that same phone as stolen to their carriers in order to get reimbursed for it. The carrier will then put the phone on a blacklist so that it can't connect to any cell networks, which effectively renders it useless as a phone. It's super shitty, but it does create an opportunity to give these crippled phones a second life as game consoles. Just search blacklisted phone on your local online marketplace and you are bound to find a bunch of really good deals.
Okay, so now that we have the back cover off this thing, let's take a look at some of these internal components and then we can discuss our plans for this project. So this big silver guy right here, that's obviously our battery. Then you have the camera modules over here, little daughter board down here that's responsible for charging. And then this guy right here, I think is the SoC, or in other words, the GPU, CPU, and RAM for the entire phone. Now, what I would like to do is take a second battery and add it right about there, a little something like that. And then I'd also like to create a little custom heatsink that's gonna take some of the heat away from what I think is the SoC. But here's the thing, I don't actually know that that's the SoC. So what I'm gonna do is use Mr. Thermal Camera here on my other phone, and we're gonna boot this one up and see if that area gets hot. Now, one interesting little quirk of thermal cameras is that they can't really read reflective surfaces. So I'm actually just gonna put a little bit of electrical tape on the back side of the little heat spreader that's on the SoC. Okay, yeah, I'm gonna go ahead and assume that that's either the SoC or the SoC is directly below that point, because that is by far the hottest point anywhere on there. So we are gonna concentrate all of our cooling right on that little point right there.
With that mystery solved, I was free to move on to designing the most important part of this whole project, the sled. The sled is a mid-frame that will allow the phone, its new heatsink, and the bigger battery to integrate more tightly with the Razer Kishi. In theory, it should make the whole setup feel like one solid unit. So I spent the rest of the day 3D modeling, 3D printing, and trying to come up with the perfect design for the sled. It took more than a few attempts.
Alrighty. Now that we are done designing the sled over the course of many iterations, actually, you know what? Why don't I show you just how many iterations there were? We are now ready to move on to the next stage of this project, which is going to be designing the custom heatsink. But first, a word about iterating. Each one of these sleds represents a small step towards my idea of perfection on this project. And this is my favorite way to design things. Rather than trying to get it all perfect in the first attempt, you can just kind of sneak up on perfection. And there's still one last iteration I want to do, but we're going to save that for a little bit later in the project. Over here on this table, we have a couple of copper sheets, some copper shims here, and this copper M.2 heatsink. And what we're going to do is combine these using a technique that I've never done before, called brazing.
Put simply, brazing is the act of joining together two or more pieces of metal using a filler metal, most commonly solder. But before I could do that, I had to, well, you know, cut my pieces of copper. And the nice thing about copper is that it's actually quite soft, so you can easily cut it with a jigsaw. Just make sure you've got some fine-toothed metal cutting blades. If you need some, I'll link the ones I used as well as all of the other tools I've used in this project down in the video description. Finally, it was time to actually start brazing. I applied a layer of flux to my first copper sheet, laid the M.2 heatsink in position, and applied heat. Once the metal was up to temperature, the solder melted on contact, and the flux helped draw it into the negative space between the two pieces. And from there, it was just a matter of adding additional layers of copper. By using 1mm thick pieces, I was able to dial in the perfect Z-axis dimension for our new heatsink. Maybe one day I'll be able to machine something like this out of a solid block of copper, but for now, this backyard solution actually worked pretty well. Once I had the rough shape that I wanted, I used a metal file to remove the excess solder, round over my edges, and just kind of dial things in a bit. And then I finished it by using a polishing pad to remove all the discoloration caused by the heat.
Whew, would you look at that? That is our new custom heatsink. So again, the idea is that it's gonna go right here and it's gonna wick heat away from the SoC and then dissipate it into the rest of the room. And you know, honestly, even if it doesn't work exactly the way I intended, it's still a huge thermal mass that's going to at least act like, well, a big thermal mass that will absorb a lot of heat coming off the processor. So now that this is done, let's move on to the next thing that I'm frankly very nervous about doing because I've never even seen anybody else do something like this before. So you remember earlier how I said one of the biggest issues with doing this is that you would burn through a normal phone's battery really quickly? Well, in order to fix that issue, we are going to make what I like to call a double battery. Or we're just gonna run two batteries in parallel. I bought two replacement batteries here and I'm gonna try and create a custom wiring harness that will effectively give us a battery that is twice as big and double our battery life. I just have no idea if it's gonna work or not, so this will be fun.
First off, do not do this at home.
Messing with batteries is dangerous and they can very easily catch fire on you. I do these things in the controlled environment that is my workshop so that you don't have to. I started by removing the battery management board from the first battery. Sounds like a bad idea, but we'll talk about why in a second. This left two exposed terminals ready to be connected to the second battery. But keep in mind, before I started this whole mad science experiment, I made sure that both batteries were charged to the same level. If you skip this step, the batteries will rapidly equalize when you first connect them and bad things will happen. With my insulating electrical tape in place, I then routed the wires from the first battery up, around, and to the battery management board on the second battery. Now, I'm not sure why, but for some reason, these boards have conveniently located auxiliary contact pads. So all I had to do was solder the ends of my wire to those pads and boom, I had two batteries wired in parallel, giving me twice the capacity at the same voltage. Then I almost blew up the whole phone. You see, I had to get the original battery out. So off came all of these connectors, and then I had to use some isopropyl alcohol to dissolve the glue holding the battery in place. But I still had to pry it out. And if you look closely here, you can see that I actually punctured the battery with my pry tool. Normally, this would cause a runaway reaction resulting in a fire. But lucky for me, I had the good sense to completely drain the battery before starting all of this, so all I got was a little sizzling sound. Definitely a close call though.
With the old battery out, I slid the new one into position, temporarily taped it in place, and then held my breath.
Ready to see if this crazy contraption works. Hold it. It works. That's such a relief. Now that we are done our double battery and our custom heatsink, we can move on to the last step of this project and the one that I kind of set aside earlier. We are going to do the last iteration of the sled or the case. And of course, because this is one of my videos, we're gonna make it a walnut.
3D printers versus CNCs. Which is better? Well, the boring truth is that they both have their advantages. But thanks to a new software update on my Xcarve, the workflow for the two is remarkably similar. Easel 3D gives me the ability to import STL files and figure out toolpaths from those. Practically, this means that I was able to take the exact same files from my 3D printer and just plug them into my Xcarve. The only difference is now I'm carving down to the shape that I wanted through subtractive manufacturing rather than additive manufacturing. Pretty neat, right? So while the CNC did its thing, I busied myself with another job, making sure that the phone didn't short itself out on that new heatsink using Kapton tape. This special tape is heat resistant up to 200 degrees and creates a non-conductive barrier, so I just put it everywhere that the SoC wasn't. This should help to keep all my little circuits safe.
So now that prep work is out of the way, we can start thinking about assembly. And I have to be careful about how I do this because, well, it's only gonna go together one way, and if I get it wrong, then I'll have to start over, which I really don't wanna do. First things first, heatsink has to get installed in this bottom piece here.
And in order to do that, I just use a little dab of silicone, which we'll talk more about in a second. But first, I added a few layers of electrical tape to insulate the backside of the heatsink from the battery. Then I glued that section to the top of the sled with some good old-fashioned wood glue, clamped it in place, and let it sit for an hour. I then repeated the same process with the other side and let the glue set up.
Pop these clamps off. It's been about 30 minutes. There we go. Look at that. That is actually quite pretty. Before we move on to installing the actual phone, I think we need to spend a little bit of time sanding and then applying a little bit of finish to this thing.
This is my favorite trick for sanding small parts. By taping the sandpaper to my workbench, I was able to reference its flat surface and sand out any seams left from the glue up. And while I was at it, I also rounded over a few hard edges left from the CNC. Then I applied a couple of quick coats of polyurethane finish. This will seal the wood and help to keep it stable over time by preventing it from absorbing any moisture from the air.
So now we're ready to basically start assembling this thing. And I'm sure one question many of you have at this point is how exactly I'm going to get heat from the SoC packet here to my new heatsink. Well, I'm glad you asked the question because I have a very special product that I want to show you guys. It's this stuff right here, K5 Pro Thermal Putty. You can kind of think of this stuff as like a very viscous thermal pad. So I'm just gonna take a very healthy dollop of it, apply it to the SoC, and then we're gonna kind of smush the two together, and it's gonna eliminate any air gap between the two and facilitate heat transfer from the SoC to the new heatsink that I made. I've used this stuff on my laptop, actually I used it on the Everything Console Mark II. It's really handy stuff if you ever had to work on an old computer.
Applying this stuff is honestly pretty funny. It literally just comes with a purple popsicle stick and you spread it on like it was peanut butter. And it's better to err on the side of adding too much, as any excess will just kind of get smushed out the sides. Now, this stuff is good for filling gaps up to about 2 millimeters, but anything above that, and you'll want to add some copper shims into the mix to help facilitate better heat transfer.
All right, let's do a little contact test before we go any further. Push this in here. Still a nice tight fit. You can really see the paste just squeezing out of there. So I am not worried about that being a bad contact. That's great. Actually, you know what? This K5 Pro is actually a pretty decent adhesive. I'm having a hard time separating the heatsink from the SoC. Oh, there we go. Look at that. Okay, now let's talk about how we are going to adhere the phone to the sled.
And the answer is more silicone. Silicone is a seriously underrated adhesive. For starters, it's really good at filling in little gaps. So once I put the phone into the sled, it'll squish down, spread out, and fill in all of those little crevices. Second, silicone provides a good strong bond, but I would classify it more as like a semi-permanent adhesive. If for any reason something breaks in the future, I know that I can pull the phone out of the sled with a little bit of elbow grease. And then finally, it's thermally resistant, so it won't deform or lose adhesion if it heats up a little bit.
All right, it's about 30 minutes later, and now I'd like to do basically the same thing to the Razer Kishi. So my hope here is that this is gonna take a lot of the kind of twistiness and just overall cheap feeling of this thing out of it by making it into one solid unit. I tried to make my tolerances really tight, so hopefully I won't need that much adhesive, and see how it goes.
I know you guys have probably heard enough about it, but one other benefit of silicone is that it's really good at bonding dissimilar surfaces together. So if you have a porous material like wood and you want to bond it to a smooth surface like plastic, it'll get the job done for you. All right, that's it, I promise. At this point, I left everything to cure and then headed home to set up all of the software.
So here we are back in the office, and I finally got all the software up and running on this thing. It actually took me a little bit longer than I expected it to, but hey, that's all in the past now, and I cannot wait to show you what this thing is capable of. It had actually kind of exceeded my own expectations in a lot of ways. First of all, for all the emulation, I'm using a front-end software called disassembly. This helps to keep things organized. Basically, it's just a launcher. So you pick the game that you want to play, and then disassembly launches the right emulator, configures all your settings, and then loads up the ROM. It also automatically downloads all the box art for your game. So now let's talk about what it can emulate. And as it turns out, it's quite a lot because the Snapdragon 888 is pretty damn powerful. To save time, let's just say that anything made before the turn of the millennium is going to run flawlessly on this machine. And it's also capable of emulating more modern day consoles like the Nintendo GameCube, the PlayStation 2, and even the Nintendo Wii. And because of the new and improved heatsink, I haven't experienced any drops in performance even during long play sessions. And the cool thing is, you can actually feel it working. It never really gets hot to the touch, but it does get warm when you're really pushing the system. The SoC stays pretty much pinned in the low to mid 40s, so you are always getting full performance. And speaking of performance, battery life. Yeah, it's pretty great. With almost 9,000 milliamp hours on tap, your hand is gonna cramp up long before this thing runs out of juice. And I think that brings me nicely to my next point. There is a trade-off to be made for all that added power. Tipping the scales at 507 grams, it's almost 25% heavier than my Switch OLED. But honestly, I don't really mind. This thing feels well built and substantial in the hand. And a big part of that is the fact that it just doesn't creak and rattle anymore. Now, let's talk about some of the sweet bonus features of this device. Because it's an Android phone at the end of the day, you have access to all the Android games that are out there. And then there's game streaming. For instance, I can use Steam Link to render the latest and greatest AAA games on my big computer and then just stream them to the handheld. Or if you're more of a couch style console gamer, well then you can just pay Microsoft $15 a month, have them render the game and stream it to you. And it can also do basically every other Xbox title. And then one last thing, I did manage to get Nintendo Switch emulation working on this thing. Now, the performance isn't quite there. Breath of the Wild struggles to hit 30 FPS, but some less demanding games do run quite well. So, overall, very happy and very excited about what this thing is capable of.
Now, the last Everything console, which might actually be better conceptualized as the Everything console Mark 1.5, was born of a search for purity. If you talk to any enthusiast, they'll tell you that emulation is fun, but it's no substitute for the real thing. See, when you're playing games on non-original hardware, there's always gonna be some compromises. It's the little details like sound and maybe a little bit more input lag and all of these small things that add up to an experience that's not quite the same as what you remember. But there is a technology out there that promises to completely eliminate all of those issues. There is a deep, dark secret hidden at the heart of modern emulation. If you really want to play your favorite games as they were intended to look, feel, and sound, well then you need the original hardware. Why is that? Well, it's because when you're emulating old retro games, you're essentially using a bunch of software trickery to interpret and convert old code. The work that used to be done by 4 or 5 chips in old retro game consoles is now being done by just 1. But doing it that way introduces problems. Things that used to happen simultaneously are now happening sequentially. And also, weird little quirks of the original hardware are just hard to replicate with software. The result is games that don't quite look, feel, and sound right. So what's the solution to the problem then? Is it just to have a closet filled with tons of old retro game consoles and a dresser filled with hundreds of cartridges? I mean, as much as I would actually like that, I think there is a much better solution for most people. I'm talking about emulation. This right here is a DE10 Nano. At the heart of this mini computer is an FPGA, or Field Programmable Gate Array. And that's just a fancy way of saying a chip that can reprogram itself. This guy can reconfigure itself on the fly to functionally become other hardware. So today, we are going to create a purpose-built emulation machine that should, in theory at least, be functionally identical to the real thing. So for the last few days, I have been plugging away at a custom design case. I started by taking some very precise measurements of the DE10 and then creating a 3D model in Fusion 360. I think it's gonna look awesome, and I even got some gunmetal gray PLA to print it in. Even
though the DE10 Nano is fundamentally different from your typical computer, that doesn't mean that it's immune to the laws of physics. So keeping it cool is going to be key to maintaining its longevity and its performance. Keeping that in mind, this first part here will be the front grille. Not only will this be the aesthetic face of our new console, but it will also be responsible for cooling down the system. And since I had about an hour to kill while it printed, I busied myself by modifying the fans that are going to slot into it.
Two twin 5-volt 40mm Noctua fans. Aren't they cute? These should be both whisper quiet and move more than enough air to keep the heat from our little 10-watt system in check. However, they do have two problems. The first was just that their wires were way too long. This was easily remedied with a couple of snips. And then, to bind all the wires together and keep everything inside the case looking neat and organized, I applied a little bit of heat shrink tubing. This stuff shrinks down to half of its original size when you apply some heat to it. Now normally I'd use a heat gun for this, but I forgot it in the shop, so I ended up just using the side of my soldering iron, which, you know what, actually worked quite well. Then it was time to solve the second problem. There's just nowhere to plug these fans in on the DE10. I mean, yeah, sure, I could have plugged them into the USB ports, but that would have been both bulky and kind of ugly to look at. So instead, I opted to crimp on these generic DuPont connectors, and then we can connect the fans directly to the GPIO pins on the DE10. But we'll talk more about that later, because just then, my first print finished. Alrighty, that's our first print done. Oh, and that's actually a very nice little print. I really like this silk PLA that I'm using. So basically these two little Noctua fans should just pressure fit right in there. These will intake air at the front here and then blow it out the back to cool down our FPGA. But clearly this is only a small part of the case, so let's keep printing. The piece I'm making here will be a removable lid for our game console, and I designed it in such a way that the top will pop right off and provide easy access to the internals in case I ever need to get in there. Oh, okay, now let's print the last piece. So this print is going to be a little bit trickier than our last two prints. These ones were very straightforward. We were just building from the bottom up and there were no overhangs, so we didn't need any supports. This next piece is a little bit more complicated with some overhangs. So the slicer has figured out where they need to go and everything. And also I knew that it would take a while. So in order to keep myself occupied and working as efficiently as possible, I saved a few little jobs. The first one was beefing up the cooling of the DE10. Yes, we've added two fans, but those fans aren't going to be pointed directly at the chips, so I opted to add these little aluminum heat sinks as well. They'll pull heat up and away from the chips and give more surface area for the flowing air to remove heat. This will ensure that everything stays nice and cool even during long gaming sessions. Next, I had to solve the problem of power delivery. The DE10 Nano is powered by a 5-volt DC barrel plug, and the integrated USB hub is powered by a 5-volt USB plug. It's kind of weird, but hey, I'm not one to judge. They also happen to be located in a really awkward spot at the top of the board. My solution is to reroute them to the back side of the case by wiring them both to this generic barrel plug adapter that I got off of Amazon. You'll see how it all comes together soon, along with the video output and the USB ports, but first, I had to perform a RAM upgrade. In order to unlock more advanced emulation on this board, it's recommended that you install at least one of these 128 megabyte modules of RAM. And no, that wasn't a slip of the tongue, I actually meant to say megabytes. This is retro gaming after all. We'll check back in on the last print in a minute, but first, I've got a hankering for some woodworking. Alrighty, so here we are in the shop, and just like in my Switch Pro video, we are going to be working on some final touches. The very first thing we have to do is just cut a little bit of acrylic. I'm sure many of you probably noticed that my lid has a big hole in it, and that's because I wanted to leave a little bit of room for a transparent side panel. This whole case is going to be very PC inspired, but also it'll be functional because it will allow you to see the DE10's diagnostic lights once everything is all assembled. Pro tip, by the way, if you're going to cut acrylic on a CNC, make sure that you get cast acrylic because it cuts much better than extruded acrylic. Next, I wanted to dress up the front of the case with a little bit of walnut. But since this case is so small, I needed that wood to be really thin. And unfortunately, I found out the hard way that the lowest my planer will go is about 3/8 of an inch, which is not nearly enough. I was pretty sure I had a solution though, so I pressed forward and cut out what I like to call the fins. I set the depth of the cut to the exact thickness I needed, knowing that it wouldn't cut the whole way through the piece of wood. Then, once I was done, I was able to sand off the rest of the thickness using my drum sander.
Lucky for me, this machine was clearly designed by a like-minded crazy person, and it let me push the sanding head right down to within 1/8 of an inch of the belt. Once I sanded off enough material, the fins just popped out in this really satisfying way. I also made a set of alternate cherry fins in case I like the look of those better, but let's be real, I'm pretty addicted to walnut. The last step was a quick oil rub finish to seal the wood and enhance the grain a little bit. So I think that's it for all the workshop stuff at this point. We're just gonna let these guys dry. Then we're gonna head back to my office, assemble this whole machine, and see if FPGAs are worth the hype, live up to the hype. You know what I mean. And also the assembly's not gonna be the easiest thing in the world. So we still got some work to do. Back at home, I removed the supports that made our overhangs possible, and then I used a little trick for these standoffs that are gonna support the DE10 Nano. Earlier, when I modeled the case, I made these holes 1/4 millimeter smaller than the threads on the standoff, and that way, when I screwed them in, they basically tapped their own threads. Next, it was time for power delivery. That generic barrel plug from earlier slotted perfectly into this alcove, and then in order to keep it from pushing back into the case, I laid down a little bit of glue. And I did basically the same thing for the HDMI port. This is actually an HDMI extension because just like the power ports, the video out was located in a really annoying spot, and I wanted all of the I/O to be routed to the back of the case. And speaking of I/O, it was time to install the USB hub. I connected its 5-volt power plug and then screwed it down. Unfortunately, I won't be able to access all of these USB ports, but the 3 that are exposed on the back of the case should be plenty for my purposes. Next came the brains of the operation, the actual DE10 Nano mainboard. Fortunately, this was pretty easy. I just screwed it to the standoffs, connected the HDMI extension and the power plug, and I was all good to go. From there on out, it was all about style. Thanks to the wonders of technology, that acrylic window that I cut earlier pressure fit right into the lid and gave me a very satisfying little peel to do. I've never been one to trust friction forever though, so I used a tiny drop of glue in each corner to secure it there. And of course, I had to integrate some magnets. So in order to attach the lid to the case, I glued 4 magnets into each of these corners. And in order to make sure I didn't mess up the polarity, I paired a second magnet to each of the corners, applied some glue to the corresponding pockets on the lid, and then mated the two together. Predictably, because this is me, I was completely unable to avoid the allure of using the walnut fins. It's just the best wood, so why would I use anything else? I did, however, mock up what the grill would have looked like had I used the inferior cherry wood, and you guys can debate in the comments about which one is best. Bonding the grill to the main case couldn't have been easier since the fans themselves acted like big alignment pins. And then the DuPont connectors that I attached earlier slid over a ground pin and a 5-volt pin on the GPIO header and will provide power to the fans. The top magnetically clicked into position and I was done. All right, well, there we go. That is the completed case. And well, I think it looks pretty awesome. That's really only half the story. We still have to set this thing up so that it can run some games. And more importantly, we have to answer the question of whether or not this is even worth it. So let's get into that. First of all, software. I'm going to be leaning very heavily on the open source Mr. project. This is a custom-made operating system designed specifically for the DE10 Nano and retro game emulation. Basically, the easiest way to set this up is to download the Mr. Fusion disk image, write that to a micro SD card, and then pop that into the DE10 Nano. I've actually already done that and put that into my DE10 because, well, my case design doesn't allow for access to the micro SD card. Next, you plug a USB Wi-Fi card in, boot up the DE10, run an update script, and at this point you can pop the SD card back out, load it up with a bunch of games that you've legally acquired, obviously, and you're basically done. It's honestly surprisingly easy and pain-free. And truth be told, I almost wish it was more complicated because as soon as you boot up your console, you're greeted with this screen that lets you pick from dozens of potential hardware cores. Each one of these represents a different retro game system that the DE10 Nano can perfectly replicate inside of its FPGA core. And the ease of setup kind of betrays just how hard many members of the Mr. community had to work in order to create these cores. If you think about it, they had to figure out and map how every single chip inside of these old retro game systems worked in order to make these. In a lot of cases, that involved X-raying the chips, sanding the tops off of them, and then physically inspecting them, and going to all sorts of crazy ends to make it all happen. So, how do you control a Mr. setup? Well, that's actually a really interesting question because it is possible to use the original controllers for whatever system it is that you're emulating. With the help of what they call a snack adapter, you could plug a Super Nintendo controller right in there. But honestly, I prefer simplicity, so I'm gonna use this 8-bit Do controller connected via USB. You could also connect it wirelessly over Bluetooth, but that would introduce input latency and kind of ruin the whole point of having a Mister/FPGA setup. And that's it for setup. So now let's dive into some testing and see if a Mister is better at emulation than a high-end PC. My testing setup was pretty simple. I set up my camera to record 240 frames per second, pressed the button on the controller, and then I counted how many frames it took for Sonic to respond on the screen. And what I found was that on average, the Mister had 81 milliseconds of input lag, and my PC had 99 milliseconds of input lag. Then I decided to test it against my mobile phone console, and there I was getting 129 milliseconds. So against really high-end hardware, you're looking at approximately a 20% decrease in input latency, and then against more mid-range hardware, it's probably more like 40%. So honestly, not as big of a difference as I was hoping, but that's still significant, and for a certain breed of purist out there, reductions like that might actually be worth all this effort. I know some of the purists out there right now are probably screaming at me because I'm running an upscaled HDMI signal. There are ways to get an analog signal out of the DE10, but for simplicity and compatibility, I decided to just stick with HDMI. Thankfully, you can configure exactly how the system upscales the image and even add in fake scan lines and filters if that's your jam. Last but not least, what are the limitations of a system like this? Because at a certain point, the size of the FPGA becomes your limiting factor. Gaming systems eventually got so complex and large, in terms of their transistor count that is, that they won't fit on this particular FPGA. And that happens right around the Nintendo 64. Unfortunately, this guy will not fit in here. I did, however, get PS1 games running, and I've heard they have a pretty close to perfectly functional core for the Sega Saturn, but that appears to be the cutoff for now. If you want to go any further than that, well then you need a more powerful FPGA, which I have heard are in the pipeline, so maybe I'll have to revisit this project in the future and do things a little bit differently. All right, everybody, that is it for my compilation of all of the Everything Console videos. Hopefully jamming all of these videos together like this gives you a better insight into A, how I plan my videos, and B, how the inspiration from one project provides the inspiration for another project. So stay tuned, because I got plenty more original content coming, including a lot more game consoles. Though I don't know if I have any more Everything Consoles left in me. We'll see.